Before we start the implementation, we are going to look at the steps that we are going to execute during the implementation so that it's easier for you to follow and understand the subsequent videos. So let's look at the bigger picture first. Our aim is to have a network of countries where the friendship or animosity details amongst these countries is stored in the network. Given this scenario, a number of unstable relationships amongst the countries emerge, which tend to move towards a stable state. So, over time, what happens? The network starts from an unstable state and it gradually moves towards a stable state. Now, what do we mean by a stable network? It's a network where there is no unstable relationship. So all the triangular relationships will be stable and the network doesn't change after that. So our first aim is to observe that how the network evolves from unstable state to a stable state. Now, second thing that can be observed in this scenario is that once the network becomes stable, the nodes in the network can be divided into two groups such that the nodes in the first group are all friends to each other. The nodes in the second group are all friends to each other. However, the nodes in the first group are enemies to the nodes in the second group. So that's an interesting pattern that emerges. The second aim of our implementation will be to observe this division of nodes into two groups, and we will see how the relationships existed amongst the countries initially and how the relationships exist amongst the countries later after this evolution. So to start with, we will create a graph with n nodes where the nodes are countries. We are going to make it a complete graph by adding n choose to edges, and we are also going to randomly assign a weight either positive or negative to all these edges, and after that we'll display the network. So this is the starting step. Once the network is created, our aim is to analyze the unstable triangles in the network. So what we are going to do is we'll create a list of all the triangles in the network. So if there are n nodes, there are going to be n choose 3 possible triangles in the network. Since we have to check whether these triangles are stable or unstable, we will store the sign details of all these triangles. Maybe we'll create a list where we'll store the sign details of each and every triangle. Now you might remember from the previous video that if the triangle has 3 or 1 positive edges, then it is stable, and if the triangle has 0 or 2 positive edges, then that triangle is unstable, right? So we're going to use this detail to check whether a given triangle is unstable or not, and we'll finally get the total number of unstable triangles in the network. Our aim now is to move the network from an unstable state to a stable state. Basically, we have to see what happens when there are unstable triangles in the network. Since we know that they tend to move towards a stable state, so that's what we are going to implement in our video. So what we are going to do is we are going to choose a triangle which is unstable, and we'll move this triangle to a stable state. Now I'll show it during the implementation. So we'll make that triangle stable, and after a triangle becomes stable, a number of relationships change, and due to that the adjacent relationships also get affected. So the adjacent triangles may become stable, or they become unstable. They can become unstable as well. So this changes the total number of unstable triangles. It can increase, it can decrease. So we'll actually see during the implementation how it fluctuates. After this moving of one triangle from unstable state to stable state, the total number of unstable triangles will change. So we are going to keep account of that. So we are going to do this until the total number of unstable triangles becomes 0. So we are going to repeat the steps 1, 2, and 3 here until the whole network becomes stable. So that is the whole idea of making the network move from unstable to stable state. Now, as I told you, once a network becomes stable, it can be divided into two groups, right? Where the nodes in first group are all friends, and the nodes in second group are all friends, and they all and the nodes in first group are enemies to the nodes in second group. So how can we create that network? Now we have a stable network and we have to divide it into two groups. How do we do that? There can be various ways that we can use to divide the network. What we are going to follow here is that we are going to choose a random node and we'll add it to first group. After that, we will look at the neighbors of this node. Some of these neighbors will be positive, some of these neighbors will be negative. As in, the sum of these neighbors will be friends, some of these neighbors will be enemies. So we are going to take the friends of this node and we will add all of them to the first group. And the enemies of this node we are going to add to the second group. After that, we'll take the friends of this node which we added to the first group. We'll take them one by one and we'll repeat the same process for them. That is, we'll look at their neighbors, we'll add the friends to the first group, we'll add its enemies to the second group. So we'll keep taking all the nodes from the first group which we have added. If they have not been processed, we're going to repeat this process. So we'll put all the friends in the first group, we'll put all the enemies in the second group, and we'll keep repeating this process until we have processed all the nodes in the first group. So at the end of this process, we will be having two groups of nodes as stated, and then we'll display the network with the two groups and we'll observe the kinds of relationships that existed amongst the countries initially and the kinds of relationships that existed amongst the countries after all this evolution. So these were the steps that we are going to follow. Let's now start the implementation.